Hi, I'm Jack.
And I'm Connor.
We are with the UMass Makerspace and are creating a video series on all things computing.
Today's video is going to be the basis on where computing came from, what it is today, and why it's important. In today's video, we're going to be covering a little bit of the history of how computers came to be, and then from there we're going to cover what a bunch of different parts in a computer are. This includes a CPU or processor, a GPU or graphics card, what memory is, or commonly called RAM, what we mean when we say storage and how that compares to memory, and then lastly we're going to cover what a motherboard is. The idea of computing goes far back into the early 1800s when punch cards were used to automate production. Punch cards would have holes in them which correlated to different data, which would then be used to perform different automation tasks. It was specifically used in looms at the time. Punch cards would later be used to calculate census data, saving the US government $5 million. Fast forward to 1936 and Alan Turing creates the Turing machine, which was used to break German codes in World War II. It's a massive machine that took up the whole room, and all future computers are based on his work. 20 years later, the integrated circuit is invented by Jack Kilby and Robert Noyce, and they called it the computer chip. And ever since then, the computer chip has been getting more and more advanced and more capable. An interesting side note, W.E.B. Du Bois Library used punch cards before barcodes were invented to keep track of books.
What is a computer and how do we really know computers today? A computer is in essence a piece of electronic hardware that performs mathematical operations. Fundamentally, this occurs at a binary level using only zeros and ones, where a 0 is low electrical signal and a 1 is high electrical signal. There are many important components of a computer, including CPUs, GPUs, memory and storage, motherboards, and power supplies, where power supply doesn't actually perform any computation, rather it supplies the power needed for the other components in the system. Every computer follows a set of instructions that tell the processor what to do with certain chunks of data it has stored in its memory. This can be anything from adding it to another chunk of data, copying it to another location inside the computer, or checking to see if the chunk of data has a certain value. For more information on how the internals of a computer actually execute, see one of our later videos. But who really cares about this stuff? This is only the really nitty-gritty stuff that electrical computer engineering people love. But we think it's great, otherwise we wouldn't have made a video on it.
CPUs, like these, are built to execute those instructions efficiently, quickly, and accurately. Computers, since they do only exactly what you tell them, are the dumbest things on the planet. In fact, they're just sand that's been taught to think. The reason why they're so great, though, is because they can do exactly what you tell them, and nothing more. Super quickly and repeatedly.
GPUs also execute instructions, but they are built for graphics, hence their name. A CPU doing all the tiny little computations to figure out what each color, each pixel on the screen should be, is very repetitive and very tedious. A normal computer these days has upwards of 7 million pixels that all need to get refreshed at 60 times a second. Why not make this easier by making tons of simple mini processors that will all try and update these pixels instead of a CPU? That's a great idea, and it's where we get GPUs from. They have tons of tiny cores, each of which can independently carry out its own set of instructions, to a point. All these cores work together to update your pixels on your screen. If you're one of those lucky folks who has a 4K screen, you better thank your graphics card for pumping out over 8 million pixels every 60th of a second.
Some people think elephants never forget, but tell you what, computers really never forget, unless they lose power, or have a system malfunction and part of their memory or storage is corrupted, or if they have physical damage to where the data is stored. Nonetheless, they're really good at paying attention to detail. A processor will execute instructions, but it'd be hard to fit so much in one little space if the CPU also had to hold all the data on the computer. Memory sticks, like these, do just that. They hold the data that the processor accesses when it's executing instructions. Just so you know, there is a faster type of memory that's actually stored on your CPU. And it's where the data is stored during the actual calculations.
What about all the data on my computer that my computer isn't currently accessing? Like those embarrassing photos of me from 2010 somewhere in my maze of folders. Yeah, that's a great point. Why would a computer's memory need to store that all the time? And that's why we have what we call storage. It's like the hard drive on your computer, and you can think of it as the bajillion other things that your computer stores in the background that isn't currently on your desktop. It's archival and meant for the long term. It's a lot slower too, which is no problem because your CPU isn't accessing it currently.
A motherboard is essentially the information superhighway between all of these components. All of these things need to be connected together somehow, and the best way to do it is definitely some sort of standardized system, so we know what goes where and that everything will be hooked up correctly.
Sounds like a ton of info, right? Well, yeah, it's over 100 years of hard work and technological innovation. Good news for us, though, is everyone who's ever started trying to do this was never born with the knowledge of how to do all of this. Ever better, there's a lot of standardization in the industry today, so building a computer is a lot less like solving a Rubik's Cube and way more like putting a 12-piece puzzle together. Hell, I built my first computer without knowing any electrical engineering, any computer science, or any craftsmanship. And you can too. We'll show you how, and maybe if you're interested, you could stick around for a bit for the other information if you're curious on how it all actually works. Hope you enjoyed. See you next time.